Here we have a problem on differential equation. So there is a differential equation given over here, and y equals to 5 when x equals to 1, and we have to solve for y in terms of x. Okay, since y has been differentiated with respect to x, we call this equation as differential equation. And in the given differential equation, if I want to solve for y, I have to get rid of this d. That is, I have to get rid of the derivative. So whenever I want to get rid of the derivative, what I need to do is I have to apply its inverse operation, that is integration. Okay, now let me write the given differential equation as it is. That is dy over dx equals to 6 times x square negative x positive 2. So before we start doing integration, first we have to get rid of this dx in denominator. So for that, we have to multiply both sides of this differential equation by dx. When you do so, this dx and dx will cancel out. So I'm getting dy equals to 6 times x square negative x positive 2 times dx. Okay, now I can start doing integration on both sides. So let me integrate both sides of this equation. So when I integrate dy, so this integration, this differentiation will cancel. I'm just getting y on the left side. Okay, on the right side, I have to integrate this expression with respect to x. Okay, now, so here in the first term, so the variable is multiplied by the constant. So whenever I do integration of a particular term, if the variable is multiplied by a constant, I have to keep the constant as it is, and I have to integrate the variable alone. Okay, when I integrate this variable x square, I have to use the power law of integration. So what is the power law of integration? Because this x square is in the form of x to the nth power. So whenever I integrate x to the nth power, what I need to do is I have to add 1 to the exponent and divide by the same exponent n positive 1. So this is the integration of x to the nth power. Okay, so let me do the same process here. That is a power rule of integration. So then I have to add 1 to this exponent. When I add 1 to the exponent, it will become 3. I have to divide by the same exponent, 3. Negative. So here we have x. And what is the exponent of this x? So there is no exponent. So we have to assume there is exponent 1. So what I need to do is I have to add 1 to this exponent. Then it will become x square and divide by the same exponent. Positive. So we just have constant over here. So whenever I do integration of a constant, so what I need to do is I have to look at the variable with respect to which I am doing integration. So here on the right side, I am doing integration with respect to the variable x. So when I do integration of a constant, the constant has to be multiplied by the variable x with respect to which we do integration. So in case if I do integration with respect to some other variable, so this too has to be multiplied by that variable. See, since I do integration over here on the right side with respect to x, so I just multiply this constant by the variable x when I do integration of the constant amount here. Okay, now we can simplify this one. That is, and also one more thing. So it's an indefinite integral because we don't have limits for the integral. So whenever I do I evaluate indefinite integral, always I have to add the integral constant c. Okay, now let's do all possible simplifications. So here 3 goes into 3 one time, 3 goes into 6 twice. So I'm getting y equals to 2x to the third power negative x square over 2 positive 2x positive c. So I've almost solved for y, but there is one more thing I have to do. That is, I have to find the value of this integral constant c using this information. That is when that is y equals to 5 when x equals to 1. That is, I have to plug in x equals to 1 and y equals to 5 into this integration to evaluate the value of c. Okay, now let me do it. So now what I'm going to do is I'm going to plug in 5 for y. Then I'm getting 5 equals to 2 times, and I have to plug in 1 for x, and 2 times 1 cube negative 1 square over 2 positive 2 times 1 positive c. Okay, 5 equals to, so the evaluation of this 1 cube is 1 times 2 is 2, and the evaluation of this 1 square over 2 is just 1 over 2 positive 2 positive c. So 5 equals to, okay, now what we can do is we can combine this 2 and 2. It will be 4 negative 1 over 2 positive c. Okay, now so our aim is to solve for c. So we have to get for these two values. For that, I subtract 4 from both sides and also add 1 over 2 to both sides. Let me complete. So when I do so, this positive 4 negative 4 will cancel out. Negative 1 over 2 positive 1 over 2 will cancel out. I'm getting already we have 5 on the left side. Now we have negative 4 positive 1 over 2 equals to, on the right side we just have c. Okay, when I combine 5 negative 4, I'm getting 1 positive 1 over 2 equals to c. So here I am adding an integer and a fraction. So whenever I do addition of an integer and fraction or subtraction, so what I need to do is I have to multiply this integer by the denominator of the fraction. Once I'm done with this multiplication, I can take these 2 as a common denominator. So when I multiply this integer 1 by this denominator 2, I'm getting 1 times 2 is 2, positive 1 whole divided by 2 equals to c. So then it can be simplified as 3 over 2 equals to c. Okay, now I got the value of c. So the value of c is one of. So now let's take this result. So we got from the integration, that is y equals to 2x cube negative x square over 2 positive 2x positive. So now instead of c we can write 3 over 2. That is, we can plug in this 3 over 2 for the integral constant c. Okay, I have solved for y in terms of x. So that is y equals to 2x cube negative x square over 2 positive 2x positive 3 over 2.